All right. If you want, hit the switch from the second from the top on the lights so you can see some of these controls a little bit better. Is that better? Okay, so last time we were cutting up a sprite sheet, right? And I think we just added a rigid body to this dude and kind of showed how gravity can work, but we haven't made him bump into stuff or anything yet, right? Okay. So obviously, I think I probably mentioned last time that if you look at back at some historic games, I think I mentioned, I think I remember Mega Man, right? That at the very beginning they have him kind of above the ground. They give this effect of him kind of jumping into the scene to get him placed onto the ground. Where if you look closely at some other older games, you'll see the characters are just slightly above the ground, and if you kind of pay attention to it, you can notice just that tiny drop at the very beginning. Rather than trying to place them pixel perfect right on the ground, go ahead and let that collision occur. Um, so that's kind of a strategy for getting them on the ground without you having to kind of do all the zoom in stuff because kind of who cares, right? It's taking them 2 seconds to drop to the ground. Okay, well, so obviously we want our zombie baby to have gravity, right? We're going to have him moving here in a few minutes, but we're going to have we want him to have gravity. And but when he drops down, we want him to land on something, right? So before we do anything else, let's get him moving some. And let's see. That's that sheet. Oh, here's the character sheet. All right. So do we have like an idle? These guys have names. Okay, so that looks kind of like a I don't know what he's doing there. It's like a wave. Okay, so that's him turning. That's him walking. Is that him kind of dancing? I want to decide what our like idle animation, what makes him look alive. That's him kind of standing there, then he turns a little bit, then he kind of that up to about here. So let's call that our idle animation. So I'm going to select all of those guys. And then so all the frames that you think are, so we could tell, we cut these out of the spreadsheet, they're all the same size, right? So what we kind of want these guys to do is play like a movie. All right. So it works a little differently if you do this in 3D Unity, but in 2D, what you do is you select everything like that. So here's all the little frames, all the little pictures that make up the kind of I'm a living baby, zombie baby thing. All right. And then we're just going to drag it out onto the screen. And it's going to generate something new for us. At least in Unity 5 it does. I expect it will do it in here as well. Okay, yep. So we're going to create a new animation. So we're going to call this zombie baby idle. I'm not sure if it'll really look like he's idle, but it's going to be close enough. All right. So this is going to be a new animation. We have kind of two pieces, two animations. We have the animation itself, And, you know, for our zombie here, we're going to have, you know, he's going to have his idle animation. He's probably going to have his running animation. He might have like a jumping animation. I think we'll use that little arm guy because I think that's how Mario worked, right? When Mario jumped, he jumped up like that because that's how he hit the rocks above him and destroyed the rocks because Mario was powerful and stuff. So we have a bunch of different animations themselves, but then we need this thing called an animation controller. All right, and we have this in a lot of different languages today. And when you throw the word controller on something, a lot of people get sort of intimidated by what that means. It's like this kind of weird machine thing. It's actually quite simple. It's just in charge of which animation is playing right now. And it gives us this little box, this little tool that we can send a message to and say, play this animation now. And actually, it also has the ability to dynamically change animations for us depending on the state of the game. Okay, so that's all it is. It's just a little, you know, orchestra director that decides that right now you're going to be doing this animation. Right now you're going to be doing this animation. Right now you're going to be doing this animation. So we're going to go ahead and save this this idle animation, and we'll see how idle he ends up looking. All right. So I'm going to go ahead and remove our old baby here that we named character, or named player rather, and we're going to click on this this new one. And we're going to name that one player. And we're going to have to, I don't remember what scale do we do 10? Yeah, 10 by 10 by 1. We don't need to change the depth of our, because we're a 2D thingy, right? All right, so we'll go ahead and move him up on the screen a little bit here. He currently does not have a gravity or a rigid body associated with him, which is okay for us for right now. So notice here that we have this guy called, what do you end up getting called? All right, this is our controller, so it just named this guy our, you know, let's just call this guy baby anim controller. So the thing that has kind of 4 little boxes and a play sign on it, that's our controller. That's the box that decides who's doing what the animation currently playing is. Now, down here, the thing that just looks like a little play sign, this is our actual animation itself. Okay, so before we do anything else, let's just hit play here. Okay, so he's kind of a jiggling, dancing baby, but he's alive. He's a guy. Okay, and maybe what we can do, that's really creepy, actually. All right, so what we can do for this animation, I'm going to go ahead and click on this animation. And let's see up here. It's on loop time. So that means it'll keep looping it back and forth, but I should be able to slow the animation down. I'm not seeing all the things I would expect to see. Maybe it's this guy. Let's move it to a quarter speed. A little slider down here. Let's see if he saunters a little slower now. I don't think it's any slower, is it? This is 10% speed. I can't tell if that's slower or not. Just leave it for now. We'll stumble upon, I'm sure, the... So I'm going to go ahead and click on this controller, and then we're going to hit open on this guy, and I think it should open the animation controller guy. All right, so this is what our controller thing looks like. So right now we only have one animation connected to this dude. It's called our zombie baby idol. And notice here that we have this thing called entry. So that's at the beginning of the game. There's a transition from this guy to this guy. And that is, oh, here's the speed. Here's where we can adjust the speed on it. All right, what's this? So what I did is I clicked on our controller. This guy down here. And then I clicked open up here. And that will open up, it's called the, what is it? The animator window. So this was the guy that was automatically generated for us. Now, we can also do these by hand. So let's assume that you've downloaded a something here. In fact, let's just do this. I'm going to go ahead and I'm going to delete that guy from there. I'm going to go ahead and I'm going to right click down here, my assets. I'm going to do create. I'm going to do animator controller. So let's say you're on one of those sites, Unity Asset Store or something like that, and you download some character models that already have some animations so that we don't have to come up with our, I was just kind of showing you how to make a stupid animation, but, they already have some animations that look better or whatever. Well, you might need to create a controller for controlling those animations. And again, controller is just kind of a fancy way of saying the dude who decides what animation is playing. And the simplest controller is a single controller, so it's going to create us. I just created a new one here. All right. And then what you would do is you would click on this guy and you would just drag your animation in. And it automatically creates that initial, if it's the first animation you drug in, it'll create that initial transition from game start to baby idle. Okay. Now, the one thing you would need to do then is when you have your player here, let me go back over here to my player. Notice the player has an animator associated with it, and you have to tell it which controller is the guy it should use for that animator. So right now, the controller it's using is the original controller that it generated for us, which doesn't have right now, it doesn't have any animations in it. So if I go ahead and hit play on this, our baby's going to be standing still. Because he does have an animator. But that animator does have a controller associated with it. And this is what. Come on. You can do it. This is what that animator says to do right now. Nothing. So we'll go ahead and we'll drag our default animation in. It automatically creates that transition for us from entry to start doing that. Now when we hit play, we have our dancing baby. Okay, so if you ever need to create your own controller, it's a right click and create new controller. And then all you would need to do is when you click on your player game object that has the animator associated with it, you would have to drag in here to controller, the controller that you're going to be, that's governing this guy's animation. Okay? So what I'm going to do is I'm going to go back into the animator. So once you have the animator open, the window kind of gets created up here. You can just click on it. It takes you in there instead of having to click on the controller and then click open each time. Now I'm going to click on this animation here, and this is where we can change the speed. All right, so the speed of this guy is currently at 1, full speed. Let's make it at 0.25. Let's see what that looks like. All right. It almost is a little too slow now, but he is a zombie. So we're going to call that good. All right, so this is what our zombie baby looks like when he's just kind of doing his thing. Okay, now let's see if we can figure out a run animation. All right, so I'm going to go ahead and we're going to go into our characters here. And I'm going to kind of go forward. Ooh. Oh, he actually has a butt. Okay, so is this running? Or maybe this is running. Well, that's running away. That's the king guy. I think that's the first frame of running. That's the third one there. I think that's the last frame of running. So I think that's running. So I'll drag this out here so it creates the animation for us. In theory, I'm going to drag this out here. Oh, I'm not in the scene yet. Now I'm in the scene. And we're going to call this guy Baby Zombie Running. Okay, so we have that guy. Now we want to start organizing our stuff a little bit here. So down here in our assets, I'm going to right click and I'm going to say create folder. And let's call this guy animations. Let's give ourselves an animations folder. Okay, now in that animations folder, now one thing we'll notice here is we already have our baby animation controller. Now we also have some couple of new controllers, the one we created and then the one that just got created a second ago. So we're going to go ahead and delete those. All right, and then let's delete the little tiny baby that got put onto the scene when we just created that new animation. And we're going to add this animation to our original controller. So right now we have two animations and an animation controller. Let's drag them into our folder. And then we'll open up that folder. I'm going to go ahead to my animator here. So here's my my controller. Now I'm going to go ahead and we're going to drag in a second animation. Here's our baby zombie running. Okay. Now, just so we can see what this guy looks like, let's go ahead and let's create a transition. So I'm going to right click on entry. And I think we could do it from here. Yeah, that does it. So if you right click on an animation and you say set as layer default state, that will automatically create the transition from entry to that guy. Now in a few minutes, we're going to create a transition from our baby idle to baby running, and we'll have to see how that transition happens. All right, so right now our default transition is the running baby, and he's probably going to run too fast right now, but that's okay. And our zombie idle, the animation exists, but there's no way of getting there. All right, so let's go ahead and run this. We should have a turbo running baby, I think. Okay, good enough. We probably have one extra frame in there because it looks like he's trying to turn, but you know, whatever. It's good enough. All right, so that's what our baby looks like when he's running. All right, and when he's idle, that's what he looks like. So he's just standing there. When he starts running, we want him to start looking like he's running. Okay? So what we're going to do here is we need to start responding to controls. So that means we need to, there's so much that we can accomplish just using the tool itself. But now we need to actually bring some programming into the situation. So we need to start writing some scripts. All right? So we need this baby, as of right now, to respond to some keys. So we're going to use the right and left keys, okay, which is the horizontal and the, I think it's the, yeah, it's going to be just the horizontal controls because we're not going to use vertical. All right, so, and I think, did I bring it up on here yet? We're just going to steal some, because what we do is we use the default input method to grab the current horizontal axis. So it's like input get axis horizontal. And that tells us what we're currently looking at. And then we use that to affect the rigid body. All right, so before we do anything else, let's go ahead and let's add our rigid body back onto this baby because this was a new baby, right? You know, from our original. So click on the baby, go to add component. We're going to choose rigid body 2D. And right now, gravity should affect that guy. And it does. I think, can we just turn gravity scale? Well, let's just go ahead and we'll get him stopping first before we do the animation. So right now he's falling. We'd really like him to go ahead and just land on this platform. Okay. So what we need to do in order for that to occur, so we have this rigid body. We need the baby. Well, we'll go to our, what do we call this guy? Go to scene. All right, so there's this guy here. We're going to go ahead and make him. We're going to add something called a box collider. So it's going to be a box collider 2D that will add to this guy. So this guy now is collidable. Okay. Go ahead and hit play. We see baby still falls through him. He's collidable, but he's not automatically a real thing that's there. Okay, in order for us to make it real, like we talked about before, we have to make it a rigid body. But we wanted to make it a rigid body that's not falling out of the sky. Okay, so we're going to go ahead and we're still selected our little platform here. We'll say add component, and let's go to rigid body. We're going to add rigid body 2D to this guy. And let's see, for the 3D rigid bodies, there's a checkbox that say gravity, so I'm assuming we have to just either turn mass off or maybe turn gravity scale to 0. Let's try that. Okay, gravity scale makes it not fall. Okay, so now this guy has a gravity scale of 0, so he's not falling. He has a box collider associated with him. We'll talk about this thing called isTrigger for our box collider later, so don't worry about that for right now. Should just be off for right now. But we need our baby to have a collider. So when he falls, those two colliders interact with each other. So we go ahead and add a component. We'll do box collider 2D for our baby. Now let's give this guy a shot. All right, baby landed on the platform and overwhelmed the platform with his weight. All right, so, but we did see the collide occur, right? So what can we do now? Well, a couple things. We can maybe go to our rigid body, and why don't we make the baby's mass 0? All right, the smallest it'll let it do is 0.0001. Now, my hope is he lands on it and it moves less. Is it moving at all? Looks like it's, I don't think that's moving. So, he's light as a feather. light as a feather. All right, so our baby has landed on this thing. And now, what we want to be able to do at this point is we'd like to have our baby to be able to move across the screen. Now, as you see right now, we don't have a whole lot of wiggle room. We have a bunch of wiggling, but not a whole lot of wiggle room. So we need to go ahead and make this platform larger. Now, let's just try something real quick and just look at how bad it ends up looking. So let's change the scale on X to be 20. Well, I guess that's not horrible. X starts getting horrible. Oop, oop. All right, so we're going to leave it at 10. And what we're going to do is we're going to duplicate this object several times. So first I'm going to rename it, so it's not just called sheet 110 thing. We're going to rename this guy floor, even though it looks like a fence. Okay, and then I'm going to, if you're on a PC, you'll hit Control-C, Mac, you hit Command-C while selected on that, or you can right-click and say duplicate. So after you've hit Control-C, then you're going to hit you're going to hit Control-V or Command-V if you're on a Mac, and that'll duplicate it as well. So we're going to duplicate this guy several times to give ourselves multiple floors. Now, they've all duplicated right on top of each other, so we need to go ahead and move these guys around. So we're going to come up here at the upper left-hand corner of the screen, and we need to choose the the dude here that has the 4 arrows. This will allow us to reposition it. So I've currently selected the floor 1, and I can just go ahead and drag that guy over and maybe just create the overlap with that last fence post or something like that. Do the same thing for your other ones. All right, so now we have kind of a walkway, and all these other floors already have all that box collider and rigid body stuff on them that we set up because we built it once and now we duplicated it. Make sense? All right, now just for a little organization over here in our scene. So down here, these are our assets. So on the bottom of the screen, these are the assets. These are the things that we have to work with in our game. Now, up here in our scene, these are the things that are actually currently in the movie scene that we're building. So let's give some organization up here, because right now we have a whole bunch of floors, and we can kind of imagine as we build out our level, we're going to have even more, right? So I'm going to go ahead and right click down here. I'm going to do something called create empty. Think of this like creating a folder. So I'll create empty, and notice it does put a game object in there. So this guy has a transform in our scene, but you can't see it. It's nothing real. So I'm going to go ahead and I'm going to rename this guy, and we're going to call this, let's call it, well, we'll just call it floors. And then what I'm going to do is I'm going to select all of my floors and drag them into that floors game object. So they become children of that guy. So to drag, you kind of drag it on top of it, and then you let go, and it throws it underneath. So now I can close that, and because you have a little arrow next to it, and you can hide all your floors. Okay, so now we have a whole bunch of things the baby can drop on. So there's our baby, and now if we can get him running, he can run across these floors. All right, so now we need to start thinking about a script. All right, let's see. For those of you on PCs, when you installed this, it would have come with Visual Studio, whatever to do this one, 2017, came with that. If you're on a Mac, I think I have a link up on the site for Visual Studio for Mac. And you'll want to get that. Did I show you how to link that? Okay, so because the default, what comes with it by default is, and we can go ahead and see this real quick. Let me go back to the assets folder. I'm going to right click, and we're going to create a new folder for our scripts. Okay, and kind of a naming convention for your scripts folder is _ scripts. And the reason they put the underscore in the front is it'll always be then at the top of your list. So when you do that, it moves it to the very front. If you don't like that, don't just name it whatever you want. All right, so we'll go into the scripts folder, and I'll right click in here, and now we're going to create a C# script. All right, and we're going to call this guy baby movement. All right, now for right now, go ahead and double click on baby movement. And that's going to open up another program. For those of you on PCs, this is going to open up Visual Studio 2017. For those of you on Macs who didn't do anything special, you may have installed Visual Studio for the Mac, it's still going to open up something called Mono Develop, right? So if you're on a Mac, you have something called Mono Develop. Mono Develop is okay. In fact, a lot of programmers prefer it over Visual Studio, but there's one big catch, which is why you're going to want to use Visual Studio for this. And that is Visual Studio automatically imports the library, so they'll do command completion for you for functions, where Mono does not. So you can either go and copy and paste like common functions that do something, or you can just use Visual Studio. So I'm going to show you how to get Visual Studio into your project. So go ahead and close Mono if you are one of those people. Go into Unity. And so on a Mac, it's under the Unity folder at the top. And well, I thought it was, yeah. And then Preferences. And then inside here, we have a thing called External Tools. And so we have our external script editor. So if you hit the drop down on that, right now yours says Mono Develop, and I doubt you have Visual Studio yet, right? You just have Mono Develop? Oh, it is? Okay, so it auto-detected it. So then go ahead and choose Visual. I thought we were going to have to browse for it. So then go ahead and choose Visual Studio. And then close this window. And then double click on your script again. Now it should open in Visual Studio. And that should be a permanent change now. You don't have to do that for every game. All right. So let's look at, this is the first time we're seeing scripts, right? In here. I have another class I'm doing 3D stuff with, so there's some overlap with what we've done. All right. So we're looking, this is the default script. So now a couple of interesting things we want to look at, and let me actually go ahead and open up Keynote here so we can get some of these things on there. Oh, you lucked out, you missed a quiz. It was a doozy. Does it look that hard? All right, so we're going to call this guy scripts, common functions. Now you see by default we get a couple of scripts here. We get start and we get update. Okay, think of start like your constructor. So start is called once when this script is born. For each object this script is attached to. Dangling preposition, but just roll with it. All right, so we can write the script once. Now, in this case, our script is going to deal with keyboard movement, so you probably don't want to attach it to a whole bunch of guys because they'll all move when you do it. But hey, maybe that's what your game requires. But in any case, we're going to have lots of scripts in our games. And a lot of times you'll write a script one time. So maybe you have an enemy on the screen. So think Mario Brothers. You got those turtle guys or whatever. They all act the same, right? Well, you don't want to have to write a brand new script for each of the turtle guys. You want to write the script once that describes the behavior of turtle guys and then drag it on every one of your turtle guys, right? So now all your turtle guys act that way. Okay, so this start function will get called once per dude that the script is attached to, but only one time when he first comes into existence. Because for example, something that start function might do, because your opportunity is that gets called once at the very beginning. So you might do stuff in there. So maybe, just to give you an example of something that would be helpful to have it called for multiple guys, maybe you want to know the initial position in world space where this current object lives. So if you have a turtle here and you have a turtle way down over here, even though they're the same kind of turtle, their position in world space is different. And you might want to know where they are initially, right? That might be important for you. All right, so you'd like that function to get called, in this case, 2 times. One for first turtle, who has his own space, one for second turtle, who has his own position in space. All right, so now we have another function called update. Okay, now it would not be overstating to say this is kind of our bread and butter of our scripts. So update, this guy gets called once per frame. And we've talked about frame rate in here. Okay, so once per frame. Now, let me show you an alternative to it. Then we have this other thing called fixed update that we can use. This guy gets called once every fixed amount of time. Okay, there is a default. Somebody looked it up last time. Was it you who looked it up, Tim? Yeah, what is it like? Okay, so it gets called many times per second, but
The idea is that it gets called at 60 FPS.
okay, I gotcha. So let's just kind of talk about the difference there. So we can think about it as many times per second. He's saying that they're trying to accomplish a consistent thing of 60 frames per second. Now let's talk about the difference then between these two. Let's say you have a really good computer with a really powerful graphics card, and that guy can play your game at 120 frames a second. And then you have a really crappy computer that has a really crappy graphics card that can run the game at 10 frames a second. If you're using the update method, now we're not on an equal playing field, right? The update method is going to get called 120 times per second on one of these guys. It's only going to get called 10 times per second on the other guy. Now, perhaps that other guy should suffer, for having a crappy computer. But, the point is that, first of all, the kinds of things we might do inside of update might be things like movement stuff, for example, or checking to see if two things are close to each other because maybe something needs to happen then. You want that to happen in as real time as possible, right? So if I'm in the game and I'm getting close to the enemy over here, you're the enemy. All right, I'm getting close to the enemy over here. Maybe once I get to a certain distance, the enemy notices me, something like that, right? So that enemy script is going to kind of know about the player because I'm from the enemy's perspective. I'm the enemy. So I'm the human playing. I already noticed the enemy standing there. But when you're playing games, sometimes the enemies are kind of standing there all oblivious until you kind of get within range, and then the enemies turn to you and they get all ticked off and they kind of run at you, right? Well, that enemy, even though we're not aware of it, is kind of constantly checking around. Like, is he close to me? Is he close to me? So if we do this on update, and she's on, the person playing the game is on a really fast computer, 120 times per second, let's say, in that case. So, if the game can be running at 120 frames a second, 120 times per second, she's going to be checking to see how close I am. Is he close enough? 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 Until finally I'm close enough. Now, we might say that's a bit of overkill, right? You don't need to check that often because the player is only going to move so fast. So the distance I'm going to move in 1/120th of a second is not real far. Okay, so if you're checking half the amount of time, 60 times a second, that's going to be plenty, right? So we want to think about the performance of this as well. So if you're having to do something 120 times every second, that takes resources, that takes time. And if we're going to decide that doesn't have to happen that often, maybe we decide that that's not a good use of our time, a good use of our resources. Okay. So now, but a couple of things to consider there. It could slow that game down, but it'll also slow another game down on updates. So you're not just hurting the fast player, you're hurting all players, okay, by doing that. Now, that doesn't mean that you don't want to put some things on update, because some things really do have that necessity to happen instantaneously, as fast as they possibly can happen. Any examples of that? Kind of things in games do we want to occur as instantaneously as they possibly can? Things that we wouldn't want there to be a delay. Go ahead. Okay, so we think about updating our screen. If you're on fixed, now we've kind of talked about what the human eye can see, right? So the human eye can see, let's call it 40 frames a second, but we can notice little flicker stuff. So there is a such thing as kind of a smoothness difference that we can perceive. But if we're talking about updating stuff on the screen, number of hit points, okay, you've taken some damage. You think back to the old Zelda game, you got hit, so you went from 3 hearts to 2.5 hearts, right? Something like that. Did you lose 1 heart at a time, or you can lose half a heart, right? You lose half a heart. So things like that. We want that to occur as quickly as possible so that we know we're in danger, right? We don't want to possibly be colliding with a bad guy for some period of time, even though from human time it's a very small amount of time, but in your game, you may get hit 2 or 3 times before you even know you've taken damage. So you want stuff like that to happen as quickly as possible. Now, one thing we need to do, though, is we need to be good stewards of the update method. We need to make sure we're doing stuff in there that isn't so complex that it takes too much time, right? Because it's going to get called again. I'm going to say in just a second, but not even. It's going to get called in a fraction of a second from now. Okay, so the stuff you're doing in there needs to be kind of quick mechanical things. Now, understand that our computers are really fast. So that's not that big of a deal for our computers. They can keep up, all right, and get stuff done. But you certainly wouldn't want to be making network calls and downloading images from websites and stuff like that in there, because those don't happen in fractions of a fraction of a second. So that's where fixed update comes in. So, as Tim pointed out, that it kind of, and I haven't looked this up, but what he says makes plenty of sense to me. So he looked up and said it tries to maintain 60 frames a second. 60 frames a second is a pretty standard number for games to maintain. First of all, it's well above what the human eye can perceive, right? So 60 frames a second is going to feel pretty smooth. Now, would a experienced gamer be able to tell the difference between 60 and 120? Possibly. There might be a slight little smoothness difference that they might notice if they're very discerning. Think of those folks as similar to the folks who are kind of what are they called? Music files. Is that what they're called? People who are like they can tell the difference between like the premium and the normal sound, like in a car when you get a new car. Any of you do that? Can you really tell the difference? I don't know. I don't listen. I listen to audiobooks, and there's not a whole lot of bass in audiobooks. I don't listen to very much music, so it's but I would assume it's kind of similar to those types of folks, where if you really have that discerning ear, and you can tell that little tiny difference, then it might be important to you to have that higher frame rate. But in general, when we're talking about games, we kind of talked about the better graphics cards. What's the purpose of having the overkill? It's to be prepared for the worst case scenario. When you walk into that crowded town and there's a zillion things happening in there, your frame rate drops from a zillion down to 230. We're still way ahead of what a human's going to perceive, as opposed to going from 60 down to 8. All right. Then you're watching a slideshow at that point. So then you'll notice. That's the whole purpose of the crazy fast. Now, we do have another limiting factor. I don't remember if we talked about this. We did, yeah, the monitor. Okay, so many of our monitors are only 60 frames a second, 60 hertz. They can only actually display 60 frames a second, even though under the hood, our graphics card's processing faster than that. It's going to be throwing things at the adapter that actually shows the stuff onto the screen, and the screen's only going to show 60 per second. Okay, so you're actually overwhelming it with information. It's going to skip some of those frames because it's not able to show them. It'll just deal with it as quickly as it can. All right, so we do have some other things that play into that, but that whole fixed update at 60 frames a second makes a lot of sense because many, many, many monitors are fixed at 60 frames a second. Typically, if you are if you're building a computer for gaming, you're building a gaming rig, you are probably going to look at like 120 hertz monitor, just because you want to experience as many of those frames as your graphics card is putting out. They do have 240 hertz monitors as well. The price goes up quite a bit when you jump to those, and I'm not sure you're necessarily going to notice for the high-end games today with the super expensive graphics cards. If you can hold a fixed 120 frames a second, you're going to be pretty happy. All right, so having 120 frames a second in front of you is fine. But a lot of our common screens, I would think pretty much everybody in here and your laptop screens are 60 hertz. So I don't care what kind of beast you have inside of it, graphics card wise, you're never going to see more than 60 frames a second, even if it can process more than 60 frames a second. And that's okay. We'd rather have the graphics card staying ahead of the screen because the screen's ahead of our eyes. We'd be in trouble if it wasn't. If your screen was 10 frames a second, yeah, now we're back to the flip book. All right, so from a programmer's perspective, we do get a little bit of wiggle room here where we get to decide where do we want to put our stuff. Now, to start off with, we're going to throw everything in update. Okay, just because it's already given us those functions, let's kind of try to experience how fast that happens. And until we start doing really complicated things, it's not going to make a difference. Okay, so update literally gets called as fast as you possibly can do stuff. Every single frame, it gets called once for every single object that's in your game. So you see how this kind of scales? So we can think about it as having a script on one of those turtles and it's getting called 130 times a second. Well, now you got 200 turtles. For 200 turtles, that script is getting called 120 or 130 times per second times the number of turtles. Things are going to get out of hand pretty quickly. All right. So one thing we might say about that is something like this is really what's dictated the evolution of our video games. This is how we've gone from Super Mario Brothers to some of our games today. Now, let me give you an example of where update comes in. You can get into trouble with update. So there was a game that was in the arcades. Not that they exist anymore, but when I was a kid, we had these things called arcades. I think they still, there's like a throwback thing. Are arcades kind of coming back now a little bit? Is that not a thing? Sort of ish, maybe. But in any case, there was this game called Double Dragon. Anybody ever heard of Double Dragon? Okay, Double Dragon was the coolest game in the arcade, and you have the line of people. You put your quarter there, you're ready to go because you're going to be next. So to play Double Dragon. Well, then they brought Double Dragon to the PC. All right, and this was in the early PCs. So we got Double Dragon for our I think it was a 286 SX 25 megahertz processor machine with a graphics card. Back then, they were just a graphics card. You weren't going and buying upgraded GPUs at this point. Okay, it could show stuff on a screen is what it could do. So that graphics card was good enough for the time, right? And Double Dragon was written for those speed graphics cards. So now back then, even though the consumer wasn't going out to Best Buy and buying an updated graphics card, they kind of came integrated on the system itself. For the most part, it probably was possible to order a new graphics card from a company, but it wasn't something that was really done. You were at the mercy of whatever that card's performance was. And every year when a new computer came out, you would expect the graphics card would be faster, right? But it wasn't one of those specs that they talked about. We weren't at that point in gaming yet where they kind of talked about the graphics performance. Really what they talked about back then was how many bits of color. You went from 8-bit color to 16-bit color to 32-bit color. Just how many colors you could deal with was the cool thing. They don't talk about that anymore, right? But what happened is we had Double Dragon running on that first computer that it was an Intel processor. It was their 286 processor running at 25 megahertz. Not gigahertz. It's the next guy down from that 20 and 25 of them. So 1,024 of them equals 1 gigahertz. So we had 25 of those guys. And you can't even compare them to what we have today anyways because they're different architectures. But regardless of that, by today's standards, a really, really slow computer. And Double Dragon was awesome. Perfect game for that. Now, several years later actually, we got a new bleeding edge computer from IBM. It's a 486 processor running at 66 megahertz, 486 DX2. Had a math coprocessor on it instead of having, it was sick. It's like a Ferrari. And then we saw that the people who wrote Double Dragon wrote it with having made some bad decisions. Game was unplayable. So many things were attached to the frame rate. So enemies, maybe they had an enemy come out every, let's call it 20 frames. Well, 20 frames a couple years before that happened at about the right amount of time for that enemy to come out. 20 frames now happened instantaneously. So you had the whole level of enemies there, right from the get-go. And your guy was flashing around. You couldn't control your guy. It was happening too quickly. So the game was broken. Now, we're probably beyond the point where that's going to happen today for our games, just because it would never make sense for us to attach spawning enemies or something like that to a number of frames. Because right off the bat, we can say that, well, if we understand that update gets called every frame, and we understand that two computers don't necessarily have the same frame rate, we probably don't want things in our game happening relative to that frame rate. We're okay if one system maybe updates the hit points or the score or something like that slightly faster than another one. That's more of a user perception thing. But we definitely don't want to impact user experience based on that. We don't want to have all the enemies come out at once. Although it was interesting the very first time. But then my brother and I were upset because we got this new computer and we can't play our favorite game. And then we fought, and I think we pulled some dresser down or something. I don't know. Boys will be boys, right? So that's where fixed update comes in. Sets us to a standard. And there's actually a couple of other ones. We have something called late update. I'll throw it on here for right now. We won't use it for, well, we may never use it, but we won't use it for a while at least. So late update gets called last. Call it low priority. All right. So if you have a lot of other stuff happening that are very high priority stuff, and you have something you want to happen as often as it can happen, but if it misses a frame or 10, not the end of the world. Okay, so that's where late update. And then there's some other ones in here too, but let's just kind of leave it at this. All right, so let's go back in and let's mess with this just a little bit. So what we're going to do is we're going to go into update here. And we're just going to print something out. Now, there's a shortcut in this. So the built-in function is called debug dot, isn't it called debug dot print? Oh, maybe they take it out. Well, it's okay. Shortcut is print anyways. Yeah, they had debug in there, right? Oh, debug dot log. That's what it is, sorry. Debug.log, there it is. So debug.log, hello world. That would be the long-winded way of saying print hello world. This guy's kind of syntactic sugar for this guy. I call it syntactic sugar. It's just a replacement that's maybe a little cleaner to write. Because when you think about it, our video games aren't going to have a whole lot of text output at the console. That's mostly for us when we're writing them for debugging. Like if something's not happening the way we expect it to happen on the screen, maybe you want to say, well, I mean, it seems like they're close to each other. I mean, let's find out where they actually are. Maybe, we see the physical sprite here, but his actual location is like way off in the wilderness somewhere. So that's where you might want to print some stuff out just to give you some feedback as the programmer. All right, but let's just see how this works. I'll just leave the print in there for right now. All right, so we have a script. All this script does is it prints hello world every single frame. And we're going to attach this script to our baby. So let's go back into Unity here. So we have the baby here. And I'm going to go ahead and I'm going to collapse some of these components just so there's less stuff on the screen so we can see the stuff at the bottom. Okay. Now, a couple different ways we can get this script in here. We can go to add component. Then we can start typing in like baby movement, and it'll find the script that way. Alternatively, we can just drag our script over there and drop it in. You can do it. There we go. So here's our baby movement script. Okay, so we have a script attached to this baby, and all that script does is print something to the console every frame. So let's go ahead and hit play. Then down here, we're going to click on our console, and notice that it says hello world here, but notice out here to the side, we see the count going up. So that's the number of times it's printing it. It just kind of collapses it for us so we don't have to see all of them. So it's already printed it 1,000 times. Right. Now, something we've seen in some previous programming classes, if I haven't shown it, if you aren't in one of the classes where you've seen it, you will, is that I/O, printing stuff to the screen, very expensive. So if you write a program that has a for loop that goes through 100,000 times and just counts, let's say just does math, sums up, just keeps adding 1 to some counting variable, and then at the very end you print it once, that program will run almost instantaneously. If instead you increment count but you print it every single time through that for loop, the program will take several seconds to run. Because that act of interrupting the CPU, when you take an operating systems class, you'll learn about this idea of interrupting the CPU, and it's called a context switch, and context switching is really expensive. So what ends up happening is the CPU, crunches numbers till it gets to a point and says, you want to do I/O? That's not my problem. So the CPU will say, okay, I'm done with you for right now because I can't do any more number crunching for you. So we're going to put you in the I/O queue. Let somebody else come in and work on the CPU. The I/O queue then will handle the I/O. Then this guy will get back in line and come back in to add 1 to count. Then it'll say, you want to print again? No problem. Context switch out, which takes time. You go and print your 2. Get back in line. You get the CPU again. 2 becomes 3. You want to print? You leave the CPU. Kind of seeing the vicious cycle there. So printing is a performance loss. In fact, one thing you will see in a lot of IDEs, and I bet you it's in here somewhere. I've never actually used it, but they definitely have it in Xcode and Eclipse and stuff like that, where you can, and that's where like the debug thing comes in. You can put debug logs throughout your code, but then you can turn off debug when you actually compile it and build it. Because what that'll do is it will build it with anything that was a debug thing disabled. So it won't hurt the performance of your game. Make sense? But generally speaking, when I'm writing stuff, I'll put a print statement in to check something. Once I get it working, I just remove the print statement. I do it myself. It's I would suspect as projects get larger and larger and larger, and you have different styles of programmers working on stuff, you can't necessarily rely on everybody kind of self-policing themselves, self-cleaning up, that kind of stuff. So that's where you might want to just turn off debugging or something like that. Okay, so right now our baby script just has him running, has him printing out hello a whole bunch of times. Now what we really want to do now is we want to start responding to movement. So I'm going to actually go ahead and I'm just going to grab some code real quick. Well, first of all, we're going to deal with this guy, and I'll explain this. Just saves us some time to go through. So I'm going to go back to my script here, and we'll go ahead and take out that print thing because we're done debugging. We're done debugging that guy. Now, at the very top here, I'm going to create a public variable. Okay, and this is very important in Unity. When you make a variable public like this, so we're creating a public variable. It's of type float, and it's called speed. Now, the language we're working with here is called C#. If you've only had Java before, hopefully this looks pretty similar. If you've only had Python before and you're starting to learn Java right now, you'll notice that this is not real foreign, right? Okay. So in any case, C#, strongly typed language. So I had to tell it what kind of variable this, what kind of value this guy's built to hold. And I'm naming him speed. Now, when I made him public, though, make sure I've saved this. We're not going to do anything else. I'm going to go back to Unity. You're going to see over here under our script, a variable pops up here. It now knows about that public variable. So now I have a way, so let's say I can go ahead and I'll just put in a 10 there. I have a way of, through the Unity interface, giving input to that script. That way we can tweak it as we want to have our program running. That makes sense? So when you need to get input into your script from Unity, manual input from us, you make it a public variable. And we'll see lots and lots and lots of examples of that. Okay, so we're going to set the speed at which our baby moves because it's going to be helpful for us because at first the baby might move too fast or too slow, and then we can just increase or decrease that value. Okay, let me go back here. Now, second thing, well, I'll just, I don't want to call it the same thing as that, so I'm going to come back in here. Now, our baby has a rigid body associated with it. So when we move this guy on the screen, what we're actually going to move is the rigid body. And all the baby sprite and stuff like that all comes with it. Okay? So we're going to need a variable to hold that rigid body. You actually don't need the variable. You can just request it each time, but we're going to use the variable for this. So I'm going to create a private variable of rigid body 2D. That's the type of value I want to hold. Okay, I'm just going to call this guy RB. Going to be the rigid body. And then in start, so this guy gets called once, I'm going to go ahead and extract the rigid body from the dude who owns this, this script. Okay? So the presumption here is that anything you attach the script to would have a rigid body. But we can attach the script to multiple things, each of which have a rigid body. So I'm going to go ahead and say this.rb is equal to this. That is the dude who owns this script. Get component. And then I'm going to give it the type of component I'm looking for. So this guy's going to be a rigid body 2D. So in this case, it's our zombie baby that has this script associated with it, right? So when I say this, I'm saying, zombie baby, please hand me your component that is your rigid body 2D. So we go back out here to Unity. That's this dude right here. Zombie baby is going to hand you this guy right here. We're not taking it away from it. We're just giving ourselves convenient access to that one thing. That way, every single time we need to access the rigid body, we don't have to say this.get component rigid body 2D. Okay? So now we have convenient access to the rigid body through a variable called RB. Okay, so let me go back in here. Now, notice they're doing this in fixed update. We can move it to fixed update here in a few minutes, but let's just do it in an update first. Notice that let me just copy this and then I'll explain each line. Just for time. All right, well, that actually explained each line, but in any case. So in update, we're creating a variable called move horizontal. Okay, we're actually not going to need a vertical, but we'll keep it in there for right now because we're going to certainly want a vertical when we start getting into like jumps or zombie baby jumping, which is terrifying, but whatever. And the way we get input, so we have this class called input, and it has a function called getAccess. Input is the class name. GetAccess must be a static method of that class. If you're just taking 250 right now, that'll make a lot more sense to you once we kind of get into static versus non-static methods. All right, but we can tell by the way we call this, and I promise you, if this is one of those things that I drill you on in 250, I just bring it up constantly, so you'll know exactly what I'm talking about then. But in any case, we're calling this function called getAccess, and the access has a string-based name. So it's called horizontal with a capital H, or it's called vertical with a capital V. These are your arrow keys. Okay, so horizontal will be left and right arrow, vertical will be up and down arrow. Okay, so we're going to get the floating point value associated with the current state of that axis. Okay, so when we hit the keys, we're moving the axis up, or moving the axis down, or moving the axis over, or whichever side. So at any point in time, it has a current state, a current position. Make sense? So we're going to grab those values. Then we're going to go ahead and we're going to create some movement. And we're creating a vector 2 movement. We actually can do this with a vector 3. Now let's talk about those two primitive types. Call this position primitives. We have something called vector 2. We have something called vector 3. Okay. Now, these might sound a little scary. This stores an X and Y position. This stores an X, Y, and Z position. That's it. One holds 2 variables, one holds 3 variables. They throw vector in front of it, and that's supposed to be scary. Okay? So these guys are just little tiny, in an older language, these would be structs. Okay? In this language, they're actual object data types, but whatever. Okay? So these guys hold, the vector 2 holds an X and Y, a vector 3 holds an X, Y, and Z. Why are we using a vector 2 here? It's 2D. Now, I said we could use a vector 3. How could we use a vector 3? Always set Z to 0. You want me to store a Z? No problem. Here, there's your Z. it's a 0. Okay, so you can pick your poison. Vector 2 is specifically made for your 2D games, but I promise you under the hood, well, I don't want to promise you. I'm not 100% certain, but it would make a whole lot of sense. Since Unity started off as a 3D engine, then when they added this idea of a vector 2, they just wrapped vector 3 with a Z set to 0. We'll call it 99% certain that's how it's implemented. All right, so we're going to get our vector 2 movement. Okay, and this is going to be a brand new vector 2 object passing in the current horizontal and vertical axes. If we only want to move horizontal, we'll go ahead and put our vertical at 0. But we just want our baby to move back and forth. That makes sense? So we'll leave it at that for a second. We'll come back in and change it. All right, now this last part, I'm going to change it to this.rb. We're going to tell our rigid body, this guy, that we want to add some force to it. The force we want to add is the movement, okay, so the speed that we just created, well, the position we just created from our vector 2, times the speed at which we want to move. That make sense? All right, so let's go ahead and run this. This should allow us to get input from the keyboard, making the baby run back and forth. Now notice the baby will not turn, so he's going to moonwalk when he goes backwards. So just make sure you always save when you save your script. Now, I think we've seen it in here that if you have your game running and you make changes, those changes are temporary. Have we seen that in here yet? So like for instance, if I have the game running here, and I go back to scene, and I change the position of that baby to here, but the game is still running. We can see it's blue up top here. When I hit stop, the baby bounces back. So you can like mess around with the scene while the game's running to try to get some like numbers. Maybe you want to know like, oh, well, I really need the transform to be this. So you can experiment with it in real time. But once the game stops, it goes back. So any changes you made were temporary changes. That does not extend to the scripts because the script is actually a file. So when you make a change to the script, I don't believe it will change at the time of while it's still running, but it might. It might run the script each time through the frame, so it's possible it would update. In fact, we could test it here in a second. But you're allowed to change your script and save it even when the game is running, and it won't revert back. All right, so let's go ahead and we'll hit play here. Whoa, 10 was too fast. 10 was too fast. All right, so let's he also went up, didn't he? Let's make this 0.1. All right, so that we could actually see it that time. All right, now I'm gonna change something here. We'll run it one more time. I'm gonna move all that code into fixed update. I saved it. Run this guy again. Okay, still just as fast. Let's go back here. So we need to slow it way, way down. Let's try that. Okay, that's too slow. Well, actually, this will be our good chance to mess with this. So it's running. That's too slow. So we're going to go ahead and we'll remove one of these zeros here. All right, now he's moving a little bit. But now we notice that our baby fell over. Now what we have on here is something called a box collider, right? Box colliders have edges. So what happened is when we started moving the baby, he tipped over. Right? Although this would kind of be creepier, it's just you got the zombie baby kind of crawling along the ground. But he has this constant collider. So he's colliding with the ground here, right? And when he collides with the ground, well, he's tipping over. All right. When kind of the edge catches. Because if you think about him as a box and we add force to that box, it gets tipped forward, the edge catches, and that's when he falls forward. You know, same thing would happen if we were pushing like a refrigerator box or something like that. All right, so a couple of things we can do here. We can go into our box collider in our baby. I'm going to go ahead and remove that guy. And we can add a different kind of collider. So I'm just going to type in collider. And we have a couple of different ones. One's called a capsule collider. So I'm going to add a capsule collider to that baby. Okay, so we get it, so it's got smooth curves. All right, so let's see if this makes a difference just as is. All right, so now he's kind of rolling. Oh, dead baby. Well, dead baby because he was already a zombie. Okay. So let's look at a different collider. We have circle colliders, probably going to make him run as well. We also have something called a mesh collider. Mesh colliders only work for 2D objects. I guess that's okay. So what we need to do here is once this baby drops, let's go back in here, go to add our components. I'm going to put that capsule collider back in. I'm going to go to edit collider, this guy. And I'm going to squeeze this capsule to basically be a line. And let's see if this gives us the effect that we are going for. Oh, the line didn't even impact. I'll make it a little wider than that, and we'll finish up here in a second. He's still tipping. Okay, well, so in any case, I'll put the assignment up. What I want you to do is for you can use the baby if you want, but we're going to be making a platformer, so go ahead and you can pick some art that you want, pick a main character, get your guy on the screen, and get your guy moving back and forth even if he's tipping over. All right, because what we're probably going to end up doing is we're going to end up turning his gravity off next time, or turning the box colliders off along with the gravity, so he's not impacting. Now he's just moving in free space. Okay, so we'll leave it at that. I will see everybody on Thursday. So I'll put that assignment up, and then your next Bible assignment is already up. Okay, I'll see everybody then.
You just want us to upload the Unity file?
Actually, why don't you just take a screenshot of, kind of like what you're looking at right here of your scene. Once we actually have it doing some stuff, we might even start taking like a video capture or something like that of it, or uploading the Unity file. We'll figure it out. But right now we're pretty simple. So, all right, sound good?
Yep.
All right, see everybody on Thursday.